So till now we have learned about factors and multiples. Now we will learn prime and composite numbers. For this we have to take few numbers and we have to find the number of factors they have. Okay, so I will write numbers here. Numbers. Okay, 1, 2, 3, 4, 5, 6 and 7. Okay, and then I will write their factors. So 1 has how many factors? 1 has only one factor because 1 can only be written as 1 multiplied by 1. There is only one method by which 1 can be represented as a product of numbers. So the factors are 1. What are the factors of 2? The factors of 2 are 1 and 2. Why? Because 2 can be represented as 1 multiplied by 2. So these two are the factors of 2. 3 has how many factors? 3 has also 2 factors. 3 has also 2 factors, 1 and 3, because 3 can be written as 1 multiplied by 3. So these two are the factors of 3. The factors of 4 are 1, 2 and 4, right? Because 4 can be represented as 1 multiplied by 4 and 2 multiplied by 2. So 1, 4, 2, these are the factors of 4. So the factors of 5 are 1 and 5, because 5 can only be represented as 1 multiplied by 5. 6 has how many factors? 6 has 1, 2, 3 and 6 as a factor. These are the factors of 6. Why? 6 can be represented as 1 multiplied by 6 and 2 multiplied by 3. So its factors are 1, 2, 3 and 6. 7 has how many factors? 7 has 2 factors, 1 and 7, because it can only be represented as 1 multiplied by 7, right? Now let us count the number of factors. Number of factors. Yes. So 1 has how many factors? 1. 2 has 2 factors. 3 has 2 factors. 4 has 3 factors. 5 has 2 factors. 6 has 4 factors. 7 has 2 factors, right? Now here I have written number up to 7. Now I will take numbers as 8, 9, 10, 11. Some more numbers I will take. Numbers. Okay. So what are the numbers left? 8, 9, 10, 11, 12, 13. Up to this I will take. Okay. Now the factors. What will be its factors? Factors of 8 will be 1, 2, 4 and 8, right? Factors of 9 will be 1, 3 and 9. Factors of 10 will be 1, 2, 5 and 10. Factors of 11 will be 1 and 11 only, because it can only be represented as 1 multiplied by 11. The factors of 12 will be, the factors of 12 will be 1, 2, 3, 4, 6 and 12, right? So it has 6 factors. 13 has how many factors? 1 and 13, because it can only be represented as the product of two numbers, 1 and 13, right? So now number of factors. So 8 has how many factors? 8 has 4 factors. 9 has 3 factors. 10 has 4 factors. Okay, 11 has 2 factors. 12 has 6 factors. 1, 2, 3, 4, 5, 6. 6 factors. And 13 has 2 factors. Okay, so we have taken numbers from 1 to 13. With these many examples, you can understand what are prime and composite numbers. Okay. So I have taken the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and up to 13 I have taken. I have written their factors and number of factors they have. Here I have written the factors of 8, 9, 10, 11, 12 up to 13 and number of factors these numbers have. This number has 9 has 3 factors. I have written like this. I have written. Now by seeing this table, can you conclude something? See, there are some numbers which has only 2. See, number of factors are 2. See, some numbers have only 2 factors. Okay. Some other numbers have more than 2 factors. See, this number has 3 factors, 4 factors. This number has 8 has 4 factors. 9 has 3 factors, 10 has 4 factors. Okay, so some numbers are there which have only 2 factors. Okay, and some have more than 2 factors. So the numbers which have only 2 factors, those numbers are called prime numbers. So what are those 2 factors? See, the number which has 2 factors has, what are their factors? Their factors are 1 and the number itself. See, 2 factors. This number also has 2 factors, right? 1 and the number itself. This number also has 2 factors, 1 and the number itself, right? 7 also has 2 factors, 1 and the number itself. Like this, 11 has also 2 factors, 1 and the number itself. 13 also has 2 factors, 1 and the number itself. Okay, so these numbers, the numbers, how can you define it? These are the prime numbers. The numbers which have only 2 factors, 1 and the number itself, are all prime numbers. Okay, and the numbers which has more than 2 factors are known as composite numbers. So the prime numbers, so what are the prime numbers? The prime numbers are 2, 3, 5, 7, 11 and 13, and there will be more prime numbers. They will also have only 2 factors, 1 and the number itself. So you can easily find out by finding their factors. If a number has only 2 factors, 1 and the number itself, those numbers will be the prime numbers. Okay, those numbers which have more than 2 factors will be composite numbers. Okay, so the composite numbers are which are the composite numbers? See, 4 is a composite number, 6 is a composite number because it has 4 factors, right? It has more than 2 factors. 8 also has more than 2 factors, it has 4 factors. 9 also has more than 2 factors. So these 8, 9, 10 and all 12 are all composite numbers because these numbers have more than 2 factors. Okay, so what about 1? See, 1 has only 1 factor. Only 1 factor because it can only be represented as 1 multiplied by 1, right? So what is 1? 1 is neither a prime number nor a composite number. It has neither 2 factor nor 3 factors. It has only 1 factor. So it is neither a prime nor a composite number. Understood? So now we have understood what are prime and composite number. Let us see their definitions. Prime number definition: the numbers other than 1 whose only factors are 1 and the number itself. So the numbers which have only 2 factors, 1 and the number itself, are called prime numbers. Okay, these are the prime numbers. And the numbers having more than 2 factors are composite numbers. Okay, so the numbers which will have more than 2 factors are known as composite numbers, right? These are the composite numbers. So what are the prime numbers which we have learned? The prime numbers are 2, 3, 5, 7, 11, 13 and so on. You can find out many more prime numbers, right? This list will go on. Okay. Now what are the composite numbers? The composite numbers are the numbers which have more than 2 factors. So the prime composite numbers start, see, the prime numbers start with 2, right? And the composite numbers start with, just now we have seen with the examples. So the composite numbers start with 4, 6, 8, 10, 9, 10 and so on are composite numbers. You can find out other composite numbers also. 20, is it a composite number? Yes, it is a composite number because it has more than 2 factors. See, 1, 2, 4, 5 and so on. Okay, so 20 is a composite number. There are many more composite numbers you can find, but the smallest composite number is 4 and the smallest prime number is 2. Okay, and what about 1? See, the number 1 has only 1 factor. Why? Because 1 can be represented as, see, 1 can be represented as a product of these 1 and 1, right? So the 1 has only 1 factor, that is the number itself. Okay, so the number 1 has only 1 factor, that is itself. See, I and E, it means that is. So the number 1 has only 1 factor, that is itself. 1 can be represented as 1 multiplied by 1. So 1 has only 1 factor that is 1. Okay, so 1 is neither a prime nor a composite number. Understood? 1 is neither a prime. Just now we have learned prime and composite numbers. Okay, if I give you some numbers and ask you to find the prime numbers among them, what will you do? You will find the numbers which have exactly 2 factors, right? Because prime numbers are those numbers, see I have written the definition, the numbers having exactly 2 factors are prime numbers. So among the given numbers, what will you find? You will try to find the numbers which are having exactly 2 factors. Okay, but if I give you so many numbers, like if I give you numbers from 1 to 100, see I have written the numbers from 1 to 100, and if I ask you to find the prime numbers among these 100 numbers, what will you do? Will you go on checking the numbers which are having exactly 2 factors? So will it not be a difficult task? So to make the task easier, a Greek mathematician gave a method, okay, by which we can find the prime numbers from 1 to 100 with a very easy method. Okay, so what I will do, I will teach you this method now. See, what we will do, we will encircle among these numbers, we will encircle the prime numbers. Okay, prime numbers we will encircle, and we will cross out the composite numbers. So we are going to learn the method by which we can find the prime numbers from 1 to 100 with a easier method. We don't have to find the factors of each number one by one and then find the prime number. No, we will find a easier method by which we can find the prime numbers from 1 to 100. This method was given by a Greek mathematician whose name was Eratosthenes. Okay, the Greek mathematician whose name was Eratosthenes, he gave this method, okay, by which we can easily find the prime numbers from 1 to 100. So what I am going to do, I will encircle the prime numbers and I will cross out the composite numbers. Now you see the method how it will work. Okay, so first I will cross out 1 because 1 is not a prime number, okay, or not it is a composite number. So now we are finding the prime numbers. So we will cross out 1 because 1 is not a prime number. Now I will encircle, see what I have written, I will encircle the prime number. So I have encircled 2 because 2 is a prime number, right? Now what is the next step? The next step is we will cross out all the multiples of 2. See, it means the cross out numbers are not the prime numbers, and I am crossing out the multiples of 4 because see, now what I will cross out? I will cross out 4, I will cross out 6, I will cross out 8, and I will cross out 10, okay, because these numbers are the multiples of 2. So the next step is to cross out the multiples of 2. See, 4 is a multiple of 2, right? 4 is a multiple of 2. It means 4 has how many factors? 4 has 1, 2 and 4. These are the factors of 4, right? 4 is a multiple of 2. It means 2 is a factor of 4, right? So 4 has factors 1, 2 and 4. It means 4 is not a prime number. It is a composite number because it has more than 2 factors. So what we will do, we will cross out all the multiples of 2. See, the multiples of any number are not the prime number because they will have the more factors than 2. They will have more than 2 factors. So we will cross out all the multiples, right? So we have to cross out the multiples of 2. So we have done up to 10. 12 is also a multiple of 2, 14, 16, 18, 20 is a multiple of 2, 22, 24, 26, 28. These are the multiples of 2 and all the multiples have more than 2 factors. So these numbers, these multiples are not the prime numbers. So we are crossing out. I am crossing out all the multiples of 2. So these all are the multiples of 2. Now The next number which is not crossed out, okay, so this number is 3 and this is also a prime number, right? So what we will do, we will encircle it because it is a prime number. It has only two factors. Prime 3 has only two factors, 1 and 3. So this is a prime number. Now we will again cross out all the multiples of 3 because all the multiples of 3 are composite number, because all the multiples of 3 will have more than two factors. So what is the first 3 and the next one is 6. It is already crossed out. 9, I will cross out 9 because it is a multiple of 3. So let us check. See, 6 is already crossed out. I will show you 9 represented as 3 multiplied by 3. So what are the factors of 9? The factors of 9 are 1, 3 and 9, right? So it has 3 factors. It means it is not a prime number. So all the multiples of 3 are not prime numbers. They are composite numbers because they are having more than 2 factors. 15, 18, 21, 24, 27, 30, 33, 36, 39, and 99. So we have crossed out all the multiples of 3. Okay, now which one is the next number which is not encircled nor it is crossed out? This is 5 and 5 is a prime number, right? So we have encircled 5. Now what is the next step? The next step is we will cross out all the multiples of 5. So the next one is 10, already crossed out. 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 95, see 100 already crossed out. So we have crossed out all the multiples of 5. Now this number, the next number, this one 6 is already crossed out. The next number is 7. We will encircle it because it is a prime number. Now we will cross out all the multiples of 7. So 14 is already crossed out. 21, 28 is already crossed out. 35, 42, 49, 56 is already crossed out. These are the multiples of 7. So the multiples of 7, we have crossed out all the multiples of 7. Now see, these 8, 9, 10 already crossed out. 11 is the next number which is a prime number. It can be represented as 11. 11 ones are 11. The product of only these two numbers gives 11. It means this number has only two factors, 11 and 1. So 11 is a prime number. Okay, so we have encircled it. Now we will cross out all the multiples of 11. What are the multiples? 22, 33, 44 already crossed out. 55, 66, 77, 88, 99 already crossed out, right? Now the next number is 12, which is crossed out. 13 is not crossed out, nor it is encircled. So 13 is a prime number because it can only be represented as a product of two numbers. 13 can be represented as 13 multiplied by 1. Only the product of these two numbers gives 13, means 13 is a prime number. Now we will encircle all the multiples of all the multiples of 13, right? Already crossed out, and the next multiple is more than 100. Okay, so all the multiples of 13 are already crossed out. Now comes 17. 17 is a prime number. If you try to find the multiples of 17 here, there is no number. 17 is a prime number because it can be represented as 17 multiplied by 1. Okay, what are the multiples of 17? Try to find out. See, all the multiples of 17 are crossed out already. Now comes 19. 19 is also a prime number because it can only be represented as the product of two numbers, 19 multiplied by 1. All the multiples of 19 are already crossed out. You can check it. See, now the next number which is not crossed out is 23, and 23 is a prime number because 23 can be represented as 23. See, there is no space. 23 can be represented as 23 multiplied by 1. So it has only two factors, 23 and 1. Okay, so it is a prime number. Try to find the multiples of 23. See, 46. See, all the it is crossed out already. The next multiple, you try to find the next multiple, it is already crossed out. What will be the next multiple? 23 3s are 69. 69 already crossed out. Like this, if you check, all the multiples of 23 are already crossed out, right? Next 24, 25, 26, all numbers are already crossed out. 29 is left, which is a prime number. It has only two factors, 29 and 1. It is a prime number. What are the multiples of 29? It is already crossed out. Okay, what is the next number, next multiple of this one? It is 29 2s are 58, right? So 58 is already crossed out. The next, all the multiples of 29 are already crossed out, right? Up to 100. We are talking about the numbers up to 100. Now the next number which is not crossed out nor it is encircled is 31. So we will encircle 31 because 31 is a prime number. It can be represented only as a product of two numbers. 31 can be represented as 31 multiplied by 1. It has only two factors. It is a prime number, right? So we have encircled 31. See, the other numbers are already crossed out. The next one is 37, which is a prime number. We will encircle it. See, 37 can also be represented as 37 multiplied by 1. There is no other way to find this number as a product of any other two numbers. There is only one method. 37 can be written as 37 multiplied by 1. Okay, so what are the multiples of 37? There are no multiples already crossed out. See, 37 2s are 74. 74, it is already crossed out. So the next is beyond 100, right? Now the next one is 41. It is a prime number. We will encircle it. The next its next multiple is 82. It is crossed out and the next will be beyond 100. Now it is 43, prime number. It can only be represented as 43 multiplied by 1. 47 is also a prime number. 47 multiplied by 1. The other numbers are already crossed out, means these are not prime numbers. These numbers are all composite numbers. Now 53 is the number left. It is a prime number. I have encircled it. Other numbers are already crossed out. 59 will be the next prime number because 59 can only be represented as 59 multiplied by 1. Only two factors. This number has only two factors. Okay, so it is a prime number. Now 61. 61 is also a prime number. 67 is also a prime number, has only two factors. Okay, 71 also prime number. 73, 79, 83, 89 and 97. So all the numbers in this list which are encircled are prime numbers. Okay, so let us count how many prime numbers are there. From 1 to 100 there are 25 prime numbers. See, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25. So from 1 to 100 there are 25 prime numbers. So all the encircled numbers like 2 3, all the encircled numbers are prime numbers and all the crossed out numbers are composite numbers except 1. 1 is not a composite number. So all the encircled numbers are prime numbers and all the crossed out number other than 1 are composite number. And from 1 to 100 there are 25 prime numbers and all the numbers except all these prime numbers, all are composite numbers except 1. Okay, so this method to find out the prime numbers from 1 to 100 with an easier method was given by the Greek mathematician whose name was Eratosthenes, and this method is known as Sieve of Eratosthenes. So I will write the name of this method, Sieve of Eratosthenes. Okay, this is the name of this method. Understood? If you like my teaching, then please don't miss to subscribe the channel and also press the bell icon so that you can get notification of the upcoming videos. Meet you in the next class. Till then, take care. Bye.